it's Sandy Chaika from Riverside Brookfield High School, just outside Chicago, Illinois. I'm here to discuss lists, and in this video, we're going to use the pseudocode for lists from the exam reference sheet to interpret code and determine the output of given code. So what will we learn? For list operations, we want to be able to evaluate expressions that use list indexing and list procedures. And for algorithms involving elements of a list, determine the result of an algorithm that includes list traversals. Now we need to know the exam reference sheet provides basic operations on lists. List procedures are implemented in accordance with the syntax rules of the programming language that you may be writing in. Traversing a list can be a complete traversal, where we access every element, or partial, where only some of the elements are accessed. Iteration statements can be used to traverse a list, and the exam reference sheet provides pseudocode for loops. It helps if you know some algorithms that might work with lists like minimums, maximums, sums, or average for lists of numbers. Looking at our reference sheet, we want to know that if we put a bracket around an I next to a list, this is referring to the element at index I of a list. We have the text and the block version. I can take the element at index I and store it in a variable X. I can also take an element X, a value X, and store it at index I of a list. Notice we have text and block versions for all of these. I can take the element at index J from a list and store it at index I of a list. I can also do some procedures here, like an insert. I can insert a value into a list at index I, and when I do so, whatever was at I will and everything after will shift one space to the right. I can append a value to the end of a list, and I can also remove the element from a list at index I. If I do so, anything that was to the right of I will now shift one position to the left. I can also find how many elements are in a list by doing length of the list. And one way to traverse a list is by using for each item in a list. So let's take a look at some practice problems. Given the procedure len of str returns the number of characters in a string called str, determine the output for the code segment below. So I want you to pause your video and take a moment to see if you can figure out what this will output. I hope you take a minute to look at it. When I look at this, we've got quite a bit of things going on here. I'm going to go in. Index is going to be set at 1. I have my list words for each word in words. So initially, index is 1. My list has words in it. I check to see if the length of word, the length of old is 3, which it is. So I'm going to remove old from the list. My index, though, will not change because I did not go into the else. So the next word that I'm going to look at is car. I check to see if the length of car is 3, which it is. So I'm going to remove car from words, but again, my index does not get updated. As I keep going through, my next word is unusual. The length of unusual is definitely not 3, so I'm going to go into my else this time and increase my index by 1. So index is now 2. Now what I'm going to do is check my next word. My next word is bold. That does not have a length of 3. So my index is going to become 3. My next word is far. Far does have a length of 3. So I remove words at 3. 1, 2, 3. I remove far. And now I have unusual, bold, and away. My next word is away. Away does not have a length of 3, so my index is going to actually change, but it doesn't matter because I have no words to look at. So everything's been observed, every element's been inspected, and what is left in my list is unusual, bold, and away. Often it takes some time to trace. I highly suggest using pencil and paper when you are tracing code. Here's another practice question. Take a look at it, see if you can figure out what the output would be in this situation. Okay, hope you paused your video and you're back now after having looked at this. So let's trace it together. Notice we have an index set to 1 and n is my length of words. Well, there's 4 elements in words, so n is 4. So I'm going to repeat everything in this block here 4 times. So in my first repetition, index started at 1. It says if words of index at words at 1 equals book. Well, song does not equal book, so I'm not going to go into the if. So I'll go into the else, or I'm just going to go outside the if. There is no else. I just go outside the if and update the index to 2. In my second iteration, index starts at 2. My words equal songs, book, video, book. Words at 2 is book. So I'm going to insert into words at index 2 the word read. So the string read now is at 2, and the other 3 strings all shifted 1 position to the right. My index here updates to 3, and now it also updates again. So my index is actually 4 at the end of my second repetition. In my third repetition, index starts at 4. I'm going to look at words of 4, song, read, book, video. Video is not book, so words does not change, but the index will go up outside of the if by 1, which makes it 5. And my fourth repetition, which is my final repetition, index starts at 5. I look at words of 5, song, read, book, video, book. Book is what I'm looking for, so I'm going to insert at spot 5 read, and this book here shifts 1 position over. My index becomes 6 inside the if. Outside the if, it goes up 1 more time and becomes 7. All my repetitions are done, so I will display words, which finally comes out to be song, read book, video, read book. So what should you take away here? Well, for list operations, we want to be able to evaluate expressions that use list indexing and list procedures. For algorithms involving elements of a list, we want to be able to determine the result of an algorithm that includes list traversals. Remember, these are important facts to know. The exam reference sheet provides operations on lists. If you do use list procedures in a programming language, there will be syntax rules that you will have to use for those according to that language. Traversing a list could be a complete traversal where we look at every element, or partial where we only look at part of them. Iteration statements can be used to traverse a list. The exam reference sheet does provide pseudocode for loops. And sometimes it's helpful to use existing algorithms that use iteration for making new algorithms. Some common algorithms for lists include minimum or maximum of a list, or finding the sum or average of a list of numbers. Please go back and review the exam reference sheet and use it to get ready for your AP exam. Thank you for watching the video. I hope you'll come back and watch some more CS Principles videos in the library. Until then, go out and have some fun with CS.